Okay, so this is about to be section 5-6, and it turns out that the section by the time we get to the end of the section, you're probably gonna learn shortcuts that make the problems very easy and very quick. And at the beginning of the section, you might feel a little overwhelmed by the strategy that I use to solve the problems, and just deal with it. Eventually, you're going to get through this and it's going to be easy. It's just there's going to be a little bump at the beginning where it's hard. In section 5-6, we're solving things called quadratic inequalities. Quadratic means there's a squared term. I'll just say there's an x squared term. And an inequality means there's either a less than sign, a less than or equal to sign, a greater than sign, or a greater than or equal to sign. Anytime we have a problem that has a less than, greater than or equal to, less than or equal to, our answer is going to contain infinitely many numbers, and we usually write them answers in interval notation. This would be an example of a linear inequality. Which is way easier than a quadratic inequality. And these you've probably done before. It's going to be linear because the exponent on the letter is 1. So something like x plus 3 is less than or equal to 10. That would be considered a linear inequality. And you probably know that you solve that by minusing 3 from both sides. And you can get an answer of x is less than or equal to 7. You might have plotted your answer on a number line and written an answer like, put a solid circle or square bracket on the 7 and drew a line off to the left because less than on a number line is left. Or you might have written an answer in interval notation. This number line, its far left edge is negative infinity, its far right edge is positive infinity, and as an interval, the answer will be negative infinity to positive 7. So all those things you've done before, hopefully. You really don't need to remember those, so if that felt really foggy to you, it hardly makes that big of a difference. But the important thing is understanding that when we have a problem that has a less than sign, a greater than sign, a less than or equal to sign, a greater than or equal to sign, then our answers are generally going to be written in a different sort of way. And the way that we're going to do in this section is interval notation. So I have a sheet here that talks real specifically about the strategies that I'm going to use. And I think I'm just going to kind of jump into the problems and then go back and forth to this sheet to explain how this sheet, this piece of paper here, is going to help you solve the problems. And then we'll see how this goes. So the first 44 problems are all problems that have less thans or less than or equal to. And then after 44, problems 45 and on have greater thans or greater than or equal to. And for each of the problems, I'm going to do exactly the same thing. And you'll find out pretty quickly that having a less than or less than or equal to, the answers kind of all look the same when you have a quadratic inequality. So each of the problems between 1 and 44, unless it's a special trick problem, will have a similar looking answer. And I'm going to start following my steps to solve problem 1. First of all, we have special cases. Special cases that have less thans are just two special. There's a special case for less thans, and there's a special case for greater thans. And the special case for less than would have the left side being squared, the right side having a negative number, and a less than or equal to sign between them. So something like this, something like x squared is less than negative 9. this would be considered a special case for a less than. Or something like x plus 3 squared is less than or equal to negative 25. Because the whole, you can't barely read that, but this has the whole left side squared followed by a less than or equal to sign and the right side negative 25. This is a special situation because the left side, if the whole left side is squared, then it's, when you square any number you get a positive number. The left side is a positive number. It can't be less than a negative number. That makes that a special case. We'll get to the special cases when they come up, and I'll explain in detail how to solve the special case and why the solution is the solution. But for less than problems, there's one special case. For greater than problems, there's another special case. The special case doesn't apply for number 2 because the special case would be the left side squared, the right side a negative number. This is the left side is completely squared, the right side's a positive number. It's not a special case, so it's a non-special case. So in the non-special case, first I'm going to solve the problem as if it had an equal sign, and I'm going to use the solutions to create intervals on a number line. So step 1 in my little step 3 on this page, the first thing I'm going to do in a non-special case is solve the problem by replacing the inequality symbol, in this case a less than or equal to, with an equal sign, and plot the two answers on a number line that also has negative infinity at the far left and positive infinity at the far right. It's a heck of a lot of words for the first step, and it's really not that involved of a step. So I don't know why I just wrote step 3. It is number 3, but in solving the non-special case problems, step 1 is to solve the problem by replacing the inequality sign with an equal sign. So this is going to be my step 1. I'm going to replace the inequality sign with an equal sign, and for most of the problems in this section you're going to get 2 solutions, and the easiest way to solve this is by square rooting, plus or minus square rooting. So that's what I'm going to do. We learned that a little bit ago, and that's going to pay off here. On the left side, when you square root something squared, you cancel out the exponents. The square root cancels out the exponent. It leaves me the x. And on the right side, the square root of 16 is 4. So my answers to this are positive and negative 4. So this is this. Solve the inequality by replacing the inequality symbol with an equal sign. And now I'm going to go to this part and plot the 2 answers, in this case negative 4 and positive 4, on a number line that also includes negative infinity at the far left edge and positive infinity on the far right edge. So I've done everything that I've written so far. I replaced the less than or equal to sign with an equal sign. I solved it, got 2 answers, which mostly I'll do is I'll get 2 answers. Now I'm plotting the 2 answers on a number line that also has negative infinity on the far left, positive infinity on the far right. Next, I'm going to create intervals. And there's normally going to be 3 intervals. So I'm going to create 3 intervals. Normally 3 intervals. If there's 2 numbers that I put on the number line other than the infinity, you get 3 intervals. You always get one more interval than numbers that you put on the number line, not counting the infinities. So I'm going to create 3 intervals, and the infinities, negative and the positive infinities, will always get around parentheses. And the non-infinities, God, that was spelled lovely. The non-infinity get a square bracket if the problem has a less than or equal to, and it gets a round parentheses if the problem has a less than. So now I'm going to finish this little step. So for this little step, the negative infinity is going to get a round bracket, then a comma, and then the next number I see is -4. Because the problem has an or equal sign, I'm going to put a square bracket. And then I'm going to go square bracket -4, square bracket 4, and then square bracket 4, comma, infinity, round bracket. So there's always one more interval than non-infinities that I put on the number line. And I think for almost every problem we're going to get 3 intervals. So now I'm done with this sentence right here. Solve the problem like it had an equal sign, use the solutions to create intervals, and now I'm going to fill in the table. So my table is going to contain the intervals, and I'm going to need another sheet of paper because that's going to take way too much room, or I'm going to need to just bump up my sheet here so you can't see the problem anymore. So the next phase in this is to create a table, and my table is going to have names. The first name is going to say the intervals. The first column is going to say the intervals. The second column is going to just be test number. The third column is going to have the original problem. The original problem is x squared is less than or equal to 16. And then I'm going to write true or false. I'm not going to write both words, I'm going to write one of the 2 words. So for every problem, my table is going to look like this, and that's what's one of the special problems. So my intervals moving from left to right in this problem, the far left interval is negative infinity to 4, the middle interval -4 to 4, the far interval 4 to infinity. So first interval, negative infinity to -4, second interval, -4 to 4, third interval, 4 to infinity. So that is in the beginnings of then fill in the table. So I get an interval column, a check number column, the original problem, the true or false headers, put my intervals down. Now I have to go about putting test numbers. And for test numbers, you need a number that's in the interval that's not one of the endpoints. The worst thing about the test number is you have lots of choices. My test number for this interval could be any number less than -4. I could put -5 in this column, I could put -6 in this column, I could put -7 in this column, I could put -1124 in this column. You just need to pick any number that's in the interval, and it doesn't matter which number you pick. I usually pick the numbers that are real close to the edge of the interval, so I'm going to pick -5. In the middle interval, I could pick -3, I could pick -2, I could pick -1, I could pick 0, 1, 2, or 3. I could pick fractions, but I never pick fractions unless there's any option. So any number between -4 and 4 I could call a test number. It doesn't matter. You have your choice of lots of numbers. I like picking numbers that are real close to the edges unless I could pick 0, because 0 is usually easy to work with. And then in the last interval, I pick any number bigger than 4. I could pick 5, I could pick 6, I could pick 7, I could pick 1,000 or 10,518 if I care to. It doesn't matter. As long as I pick a number that's bigger than 4 and less than infinity, my number is okay. And usually if I can't pick 0, I pick a number that's close to the edge of the interval. In this case, I'll pick 5. So I've filled in my test numbers. Now what I need to do with the test number is plug it into the original problem. So I'm going to go negative 5 squared is less than or equal to 16, and 0 squared is less than or equal to 16, and positive 5 squared is less than or equal to 16. It's not enough to do that. Now I need to simplify, and I don't need a calculator to simplify this. Negative 5 squared is negative 5 times negative 5, which is positive 25. That simplifies to 25 is less than or equal to 16. The next one, 0 squared, is 0, so that reduces to 0 is less than or equal to 16. And the third one, I get 25 is less than or equal to 16. So now I've got the second column done. I'm going to move on to the third column. To move on to the third column, I look at the statement I have here and decide if it's a true statement or a false statement. The statement that says 25 is smaller than 16 is false, because 25 is bigger than 16. The next statement says 0 is less than 16, or 0 is smaller than 16. That's a true statement. The last statement, 25 is smaller than 16, that's a false statement. Technically, it's 25 is less than or equal to 16, but I can think of as a less than is smaller for this. I'm basically done. My answer is just the true interval or intervals. So the answer to problem 1 in interval notation is the true interval, and the true interval is on this line. It's the interval from -4 to +4. So I'm going to be real consistent and do every single problem, unless it's a special case, this way. So first I'm going to solve the problem by replacing the inequality symbol with an equal sign. We should get 2 answers more often than not. I'm going to plot those 2 answers on a number line that also contains a negative and positive infinity. I'm going to create more often than not 3 intervals. The infinities will always get round parentheses, and the other numbers will get square brackets if you have a less than or equal to, round brackets if there's a greater than. When we get to problems 45 and on, you're going to get square brackets if you have a greater than or equal to, round brackets if you have a plain ordinary greater than. But that won't come up to problem 45. I won't worry about that just yet. So, problem 4. First step, change out. So solve by replacing the less than or equal to with an equal. So it's going to give me x squared equals 45. Solve this by square rooting. So I'm going to go square root of x squared equals plus or minus the square root of 45. On the left side, square rooting x squared gives me an x. On the right side, I'm going to reduce square root of 45 with my calculator. I'm going to get a decimal approximation and a square root answer. I'm going to need both. So I'm going to break out my calculator and do square root of 45, and I find out that's 3 square root of 5. And right off to the side, I'm going to hit the SD key. This is plus or minus 6.7, close enough. So I'm now ready to create intervals. So on my little steps right here, I solved by replacing the less than or equal to with an equal sign. And now I'm going to create a number line, negative infinity and positive infinity on the edges, and then the numbers I've gotten in between. So my interval is going to go, my number line is going to go negative infinity, negative 3 square root of 5, positive 3 square root of 5, positive infinity. Create my intervals. Infinities always get round brackets, and the numbers get square brackets when there's a less than or equal to. So I'm going to get square brackets again. So I'm done with all the preliminary work. Now I'm going to make my table. My table is going to say intervals, test number, then I'm going to put the original problem, and then true or false. So my first interval is the interval from negative infinity to negative 3 square root of 5. My second interval is the interval from negative 3 square root of 5 to positive 3 square root of 5. And the last interval is from positive 3 square root of 5 to infinity. To figure out what number I can put in, I know that this number right here is negative 6.7. So I can put in, something I can put in negative 7, I can put in negative 8, I can put in negative 9. I can put in any number less than negative 7, less than negative 6.7. That's why I find the decimal approximate, because I have no idea what number makes sense to put in unless I know what that is. And anything to the left on the number line of negative 6.7 is suitable, so I'm going to put negative 7. The second interval goes from negative 6.7 approximately to positive 6.7. Because 0 is in that interval, I'm going to test 0. And my last interval goes from 6.7 to infinity, and I'm going to plug in 7 because it's bigger than 6.7, which I need, and it's not that big. Now I'm going to check in each. For the first one, I'm going to go negative 7 squared is less than or equal to 45. The second one, I'm going to go 0 squared is less than or equal to 45. And the last one, I go 7 squared is less than or equal to 45. First one, I get 49 is less than or equal to 45. Middle one, 0 is less than or equal to 45. Last one, 49 is less than or equal to 45. Fill in the last column. 49 is not smaller than 45, so this is false. Middle one, 0 is smaller than 45, so I'm going to put true. In the bottom one, again, 49 is not smaller than 45, so I put false. My answer is the true interval, so my answer to problem 4 is just the interval from negative 3 square root of 5 to positive 3 square root of 5. Hardly readable. It's negative 3 square root of 5 comma positive 3 square root of 5. Okay, I'll keep moving on, and eventually we're going to get to a special case, but the special case involves the left side being squared, the right side being a negative number. It's not that yet, so we're not worried about it yet. Okay, step 1, solve it by replacing the less than with an equal. So I'm going to go x squared equals 49, and then I'm going to go square root plus or minus square root. On the left side, square rooting cancels out a square, leaves me the x. On the right side, I get plus or minus 7. Now I'm going to make my number line. I'm going to have negative infinity on the far left edge, positive infinity on the far right edge, negative 7 and positive 7, somewhere between the infinities. And now everything's going to get round brackets. The infinities always get round brackets. And if you don't have the or equal to, the other numbers get round brackets as well. So my interval is going to be negative infinity to negative 7, negative 7 to 7, 7 to infinity. And now my table, my first column is going to say intervals. My second column, I need a check number. My third column is the original problem. My last column is true or false. First intervals from negative infinity to negative 7. Second intervals from negative 7 to 7. Third intervals from 7 to infinity. In the first interval, I'm going to check negative 8. 0's in the middle interval, so I'm going to check 0. In the last interval, I'm going to check positive 8. You don't need the same check numbers as mine. I could have checked negative 11 in this interval. I could have checked 3 in that interval. I could have checked 18 in this interval. As long as the number's in the interval, it doesn't matter. Your far right-hand column will say the same thing. So first, when I go negative 8 squared is less than 49, which gives me 64 is smaller than 49. Middle one, 0 squared is less than 49. That gives me 0 is smaller than 49. Last one, 8 squared is less than 49. That gives me 64 is less than 49. Top one is false, because 64 is not smaller than 49. Middle one is true, because 0 is smaller than 49. Bottom one is false, because 64 is not smaller than 49. Hopefully you're already starting to see a pattern in the table. All the less than problems that we do, because they're all quadratics, are going to have that same feel in the table. So my answer is just the interval that I write true next to, and the interval that I wrote true next to is the interval from negative 7 to positive 7. Move on to 8. X squared is less than 24. Not a special case because the right side's just not a negative number. So I'm going to change the less than sign to an equal sign and get x squared equals to 24. And then I'm going to square root and plus or minus square root. Square root of x squared is x. The square root of 24, I'll rely on my calculator. The square root of 24 is 2 square root of 6. I'm going to SD it to get a decimal. So it's about plus or minus 4.9. It's a little bit shy of 5. And then put my number line, negative infinity, negative 2 square root of 6, positive 2 square root of 6, positive infinity. All the intervals get round brackets because you don't have an or equal to. So negative infinity to negative 2 square root of 6, and then negative 2 square root of 6 to positive 2 square root of 6, and then positive 2 square root of 6 to square root of 6 to infinity. Create my table. The intervals that are going to be negative infinity to negative 2 square root of 6, and negative 2 square root of 6 to positive 2 square root of 6, and positive 2 square root of 6 comma infinity. Then I'll do my check number, and again this is about negative 4.9. That's about positive 4.9. Helps me understand my check number. Here my check number in the bottom, it might be 5 because 5 is bigger than 4.9. In the middle I go from a negative to a positive number, so 0 is in between those, so I'll use 0. And here negative 5 is to the left on the number line of negative 4.9, so I'm going to use it. Write my original problem down. X squared is less than 24. Then plug the numbers in. Negative 5 squared is less than 24, which reduces to 25 is less than 24. Then 0 squared is less than 24, which gives 0 is less than 24. And then 5 squared is less than 24, which is 25 is less than 24. And now my true or false. Top one says 25 is less than 24, that's false. Middle one says 0 is less than 24, that's true. Bottom one says 25 is less than 24, that's false. So my answer is only the true interval. So my answer is going to be negative 2 square root of 6 to positive 2 square root of 6. All around parentheses because the problem itself doesn't have a less than or equal to, it just has a less than. 10's a special case. The reason it's a special case is this always simplifies to a positive number. No matter what number I plug in for x, that's always going to equal a positive number. This side is negative. No positive number is ever less than or equal to negative 16. And that's what I'm trying to find. I'm trying to find numbers I can plug in for x that when I square them I get a number less than or equal to negative 16. That's impossible. So this is special case 2. The left side is squared, the right side is a negative number. This has a less than or equal to negative number. And the hint to this, it's a beautiful thing. It says see problems 9 through 24. I'm on number 10. That's right in that gap there. There's no solution to this. If I do any algebra, I'm not sure what's going to happen, but I don't think my algebra, I think I'm going to get false, false, false when I go to do the my table, but I don't have to, because logically the left side is a positive number. No positive number can ever be less than a negative number, so there's no work to do for this special case. The answer is there's actually no solution to this, because there's no number I can plug in for x to make the left side smaller than the right side. And so the special cases, you kind of hope for the special cases. And the special case is, you know, I tried to write them down before. This would be a special case for a less than. This would be a special case for a less than. If the whole left side is squared and you're separated by a less than or equal to, and the right side is a negative number, that whole problem doesn't have a solution, because the right side is always going to reduce to a positive number. When you change the x to a number and simplify, you're going to always get false, because the left side is always going to be positive, the right side is always this negative number. You'll never get a true statement. You'll never get that, 0 is less than 16 kind of thing that we've been getting. So all the special case problems are no algebra if I can recognize them. If I try to do the algebra, I think it's not going to fail me. My table is going to give me false, false, false. 12 is also a special case. Why is it a special case? Because the left side is only being squared, so the left side is completely squared. The right side is a negative number. And case 2 is the special case where you have a less than between the two, and this is another no solution. If I try to do any algebra, actually I think I'll get I's when I try to find the critical numbers, and I wouldn't even know how to do intervals on a number line with the I's, because a number line only contains numbers without I's. It doesn't contain imaginary numbers. And a whole string of these are just going to be no solution, no solution, no solution, no solution for a bit here, just because I wanted to just make you see a bunch of them and maybe some different varieties of no solution problems. So this is another special case too. The reason it's no solution and I call it special case 2. Left side is squared. The other side has a less than or equal to between them. The other side has a negative number, probably all the way up to 24. I'm going to get answer no solution and stop. Because this is always positive, it can never be less than a negative. My answer to 14 is going to be another lovely no solution. 16, same deal. Left side is squared. Right side is a negative number. There's a less than between them. And anytime that happens, if you do try to make a table I think you're going to get confused more so than anything, because the intervals are going to contain i's, and then you can tell. If you start getting i's when you try to find the intervals, you can tell that that's a special case. Like if I tried to solve this, I'd go the square root of x squared. I'd change this to equals first, and then I'd get goes equals plus or minus the square root of negative 24. And my calculator, when I do this square root, do the square root of negative 24, my calculator would spit back an I, and then immediately I can tell that's a special case. If I start getting an I, then it's a special case, and I have to figure out what kind of special case it is. There's one special case for less thans, there's a special case for greater thans. Because this is a less than, I'll write no solution. 18, just as long as the entire left side is squared, meaning there's nothing outside the parentheses that's not the exponent doesn't apply to, that's still a more abstract, but it's still the special case. This left side is always positive no matter what number. Like if I put in 0 on the left side, I'd go 0 minus 2 squared, I'd get minus 2 squared, which is positive 4. No matter what number you plug in on the left side for x, after you subtract 2, you have to square it, and the squaring it's going to make it positive. So this is saying that this side, which is always positive, is less than or equal to negative 16. That can't ever happen. There's no value of x that I can plug in to get a number smaller than negative 16, because when you put a number in for x, you subtract 2 and you square it, you get a positive number. So that makes this a special case again. Apparently we have a few more special cases, and I like them. They go a lot faster. 20 is just like 18. The whole left side is being squared. There's a less than or equal to. It doesn't matter if it's a less than or equal to. That still makes it special case 2. If it was a greater than or equal to, it's special case 1. We're not doing the greater thans to the second half of this section. So it's another no solution. Probably, oh, this is not a special case here. X plus 5 squared less than 16, that's not a special case because that's a positive number. So now I need to go and solve it regularly. How do I solve it regularly? First thing I do is I get the numbers for the number line by replacing the less than sign with an equal sign. So I only get special cases when you have a negative number over there. When it's a positive number, it's not a special case. So I'm going to solve this by square rooting, plus or minus square rooting. On the left side, the squaring gets canceled out by the square root, leaves me an x plus 5. On the right side, the square root of 16 is 4. I'm going to minus 5 from both sides. Hopefully remember some of the math we did earlier in this chapter. This gives me minus 5 plus or minus 4. And I need to make this x equal minus 5 plus 4, which is minus 1. And x equal minus 5 minus 4, which is minus 9. But this is all from section 5.1, this kind of solving. So I'm going to make my number line. I get a negative infinity on the far left edge, positive infinity on the far right edge. Negative 9 goes further left than negative 1. I get all round parentheses because I don't have the or equal to. So I get a negative infinity to negative 9, a negative 9 to negative 1, and a negative 1 to infinity for my intervals. Now my table. My interval column, I'm going to write negative infinity to negative 9, and negative 9 to negative 1, negative 1 to infinity. Maybe you can predict how the columns are going to come out here. Hopefully you can. For my test numbers, in this one I'm going to put negative 10 because it's close, it's in the interval, it's close to the edge. Here I can't put 0, they're both negative. I'm going to put negative 2, it's in the interval, it's kind of close to an edge. And here I go from a negative 1 to a positive infinity. There's the interval where 0's in. I always try to take advantage of the 0 when I can. And because 0 is in that interval where you switch from a negative to a positive, that's where it's going to go. And now I'm going to put down the problem. X plus 5 squared is less than 16. For the first one, I'm going to go negative 10 plus 5 squared is less than 16. Negative 10 plus 5 is negative 5. So this gives me negative 5 squared is less than 16, which gives me 25 is less than 16. For the middle one, I go negative 2 plus 5 squared is less than 16. That gives me positive 3 squared is less than 16, and that gives me 9 is less than 16. The bottom one, I do 0 plus 5 squared is less than 16. That gives me 5 squared is less than 16, which runs me to 25 is less than 16. Now I need the true-false column. 25 is not smaller than 16, that's false. 9 is smaller than 16, that's true. 25 is not smaller than 16, that's false. My answer is the true interval. Hopefully you're starting to catch that pattern for all the less thans. I don't know what the heck I was writing there. My answer is going to be negative 9 to negative 1. So if it's not a special case and it's a less than, you're starting to see the middle of my table giving the true and the outside's giving a false. That's not a coincidence. It's going to keep happening. 28's not a special because that's positive. So I'm going to go make it like it's an equal sign. X plus 8 squared equals 36. Solve that to get my number line ready. Square root plus or minus square root. This is going to give me x plus 8 on the left side equals plus or minus 6 on the right side. Now I'm going to minus 8 and minus 8. That's going to give me x equals minus 8 plus or minus 6. I make up the two problems. X equals minus 8 plus 6, and x equals minus 8 minus 6. The minus 8 plus 6 have opposite signs, so I subtract the number, take the sign of the larger, get a negative 2. The minus 8 minus 6 have the same sign, so I add the numbers and keep them negative and get a minus 14. So my table, first interval, negative infinity, whoops, forgot the number line, negative infinity, negative 14, negative 2, positive infinity, gives you negative infinity to negative 14, negative 14 to negative 2, and negative 2 to infinity. I don't really even need to make that. After I do a bunch of them, I know what the table's got to be. But anyways, negative infinity to negative 14 is one of my intervals. Negative 14 to negative 2 is a second interval, and negative 2 to infinity is the third. So I'm getting lazier with my tables because I'm getting comfortable here. My check number here is going to be negative 15. My check number here is going to be negative 3. And this is the interval that goes from a negative to a positive, so I'm going to check 0. And now I need to check in x plus 8 squared is less than 36. So the first one I'm going to go negative 15 plus 8 squared is less than 36. Feel like my mind is starting to get spongy, so let me just do this on my calculator. So I'm going to go parentheses negative 15 plus 8 parentheses squared. Just enter the left side, and that gives me 49 is less than 36. And now for this one I'm going negative 3 plus 8 squared is less than 36. So again, cheat. I don't know if it's really cheating, but it's maybe being clever. Negative 3 plus 8 squared is 25. You can see that. And that gives me 25 is less than 36. And the last one gives me 0 plus 8 squared is less than 36. Do that. 0 plus 8 squared. And I get 64 is less than 36. Now I go for my true false. 49 is not smaller than 36, so that's a false. 25 is smaller than 36, that's a true. 64 is not smaller than 36, that's a false. So my answer is going to be the interval from negative 14 to negative 2. Okay, 26. Oh, 26 is the first one where I'm actually going to have to factor. It's a little bit different, but shouldn't be terribly hard. So for 26, first thing I do is pretend it has an equal sign. And when I pretend it has an equal sign, I write x squared plus 5x minus 6 equals 0. And I can't solve this with square rooting. I'm going to solve it by factoring. I'm going to factor this into x plus 6 times x minus 1 equals to 0. So hopefully your factoring skills tolerate me doing it like this. If you can't factor that, you can use the quadratic formula to get the answers that we need for the number line. Now I'm going to go x plus 6 equal to 0, x minus 1 equal to 0. And I'm going to get negative 6 and positive 1 for my number line. And I'm going to get some square brackets this time because I have an or equal to again. So for my number line, I'm going to get a negative infinity, a negative 6, a positive 1, and a positive infinity. And I'm going to get square brackets on the non-infinities. So my table is going to have my intervals. The far left interval is negative infinity to negative 6. And then I get the interval from negative 6 to positive 1. And then I get the interval from 1 to infinity. Test number here, I'm going to try negative 7. Here I go from a negative to a positive, so I'm going to try 0. And in here I need a number bigger than 1, I'm going to try 2. And then I'm going to pull out the original problem. X squared plus 5x minus 6 is less than or equal to 0. For the first one, I'm going to go negative 7 squared plus 5 times negative 7 minus 6 is less than or equal to 0. Calculator time. So on my calculator, so negative 7 squared plus 5 times negative 7 minus 6. This gives me 8 is less than or equal to 0. The next one I'm going to do 0 squared plus 5 times 0 minus 6 is less than or equal to 0. Easy to do on my calculator because I'm just going to back arrow now. Back, 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 get to the negative 7, delete, delete, type a 0. Go back again, get to the negative 7, delete, delete, type a 0. That's what I was wanting to enter, and that gives me negative 6 is less than or equal to 0. And for the last one, I'm going to go 2 squared plus 5 times 2 minus 6 is less than or equal to 0. Again, just kind of not really cheating, but kind of cheating. Delete 2, delete the 0, type a 2. It's a huge thing to be able to do on this calculator because it really speeds up when you have repetitive checkings to do. And that gives me 8 is less than or equal to 0. So 8 is not smaller than 0, so that's false. Negative 6 is less than 0, that's true. And 8 is not less than 0, that's false. So again, the same thing's happening with my answer. I think I could roll the dice and write an answer down without doing the whole table if I really wanted to. And you'd be safe in this test for the less than problems. If you make your tables just like I make my tables, and it's not a special case, it's going to be false, true, false every time for the less thans. Whether that's a less than or equal to, won't matter. Same thing for 28, so I'm going to start off getting ready for my number line. I'm going x squared plus 5x minus 50 equals 0. I can factor this in my head. If you can't factor this, you can get the answers using the quadratic formula, but I factor pretty quickly. So I'm going to factor this into x plus 10 times x minus 5 equals 0. If your factoring isn't working so well, come visit me and I can reteach you factoring. The numbers I'm going to get on my number line are x equal negative 10 and x equal positive 5. And my number line is going to look like negative infinity, negative 10, positive 5, positive infinity, square brackets this time because they are equal to, so negative infinity to negative 10, negative 10 to 5, 5 to infinity, and then my table, the intervals are negative infinity to negative 10, negative 10 to positive 5, positive 5 to infinity. First one I'm going to check x equal to negative 11. Second one goes from negative to positive, that's why I check my 0. The last one I'm going to check 6. Where am I going to check them? I'm going to check them into x squared plus 5x minus 50 is less than or equal to 0. So I'll go negative 11 squared plus 5 times negative 11 minus 50 is less than or equal to 0. Calculator time. I'll get parentheses negative 11 squared minus 5 times negative 11 minus 50, and that gives me 126 is less than or equal to 0. For the next one, I'm going to go 0 squared plus 5 times 0 minus 50 is less than or equal to 0. So back up here, delete the negative 11, type in a 0. Back up here, delete the negative 11, type in a 0. Gives me negative 50 is less than or equal to 0. In the bottom one, I'm going to go 6 squared plus 5 times 6 minus 50 is less than or equal to 0. So now I need to change everything to 6. Change that 0 to a 6. Change that. I put a negative 0, but it's still 0 to a 6. And I get negative 44 is less than or equal to 0. And then 126, ooh, I messed up here. How did I get negative 44? Oh, I don't know. 6 squared, which is 36. I messed up somewhere, and I'm not sure where I messed up. So let me fix this. This one's supposed to be 6 squared, as you can see it now, plus 5 times 6 minus 50. Should have gotten 16. I don't know what I did to get 40 minus 44, but I could tell I was getting messed up because I was getting a true down here and I shouldn't. So 126 is not smaller than 0. Negative 50 is smaller than 0. 16 is not smaller than 0. If you get an answer that's for a less than that's not the middle one, I think you messed up. There are special cases that we can make, but not with squares. You need cubes or fractions to get with a less than not to be a false, true, false. Ooh, 30. I don't want to factor this. I'm going to bust out the quadratic formula. So I need to solve 4x squared minus 4x minus 3 equals to 0. Could factor that with bottoms up, but I'm just going to go a equal to 4, b equal to negative 4, c equal to negative 3, and get negative 4 plus or minus the square root of negative 4 squared minus 4 times negative 3 all over 2a, which is 2 times 4. And I bust that out in my calculator, so best I can. Fraction negative parentheses negative 4 plus square root parentheses negative 4 squared minus 4 times negative 3 all over 2 times 4. So hopefully this skill has not left you. and I get x equal to 3/2. And remember, I need to go backwards now and change the positive to a negative. So I'm going to back into this, get up in the numerator. Eventually I'll get there. Get my cursor flashing right to the right of that plus sign. Delete, change the plus to a minus. That's the minus part of the plus or minus. And that gives me -1/2. So the numbers for my number line are -1/2 and +3/2. So my intervals are going to be -infinity, then I'm going to pop down a -1/2, then I'm going to put down a +3/2, then I'm going to put an infinity. My intervals are going to be -infinity to -1/2, and then -1/2 to 3/2, and then 3/2 to infinity. And so my table, first interval -infinity to -1/2, second interval -1/2 to +3/2, last interval +3/2 to infinity. In the first interval, I'm going to check -1 because -1 is less than -1/2. Middle interval goes from negative to positive. I'm going to check 0. 3/2 is 1.5. In this interval, I'm going to check 2. How am I going to check them? I'm going to go 4x squared minus 4x minus 3 is less than 0. If you wanted to, you probably could just go false, true, false, and say your answer is -1/2 to +3/2. I'm sure that's right, but I'll do it all the way out. So I'm going to go 4 times -1 squared minus 4 times -1 minus 3 is less than 0. Calculator time. It's hard to see this, right? It's always like right where I need to be. So this one's going to be parentheses, no, 4 parentheses -1 squared minus 4 parentheses -1 minus 3, and that's going to give me 5 is less than 0. That's why I was able to put false there. Then the next one, I'm going to go 4 times 0 squared minus 4 times 0 minus 3 is less than 0. So I'm going to change, back up here, delete, delete, 0, back up here, delete, delete, 0. That looks like that. That's just, the glare is just frustrating. This gives me -3 is less than 0. And for the bottom one, I go 4 times 2 squared minus 4 times 2 minus 3 is less than 0. Easy enough to check this, so back up here, change that to a 2, change that to a 2, and you get 5 is less than 0, which is false. So my guess at my answer was perfectly right. I think I'm going to get to 44 and then stop it and do the greater thans on a separate video. 32, I'm going to go 5x squared plus 13x plus 6 equals 0. Quadratic formula again, I don't figure I want to do this otherwise. So the A is going to be 5, the B is going to be 13, the C is going to be 6. I'm going to go negative B, which is -13, plus or minus the square root of 13 squared, you don't need a parentheses when the B is positive, minus 4AC, which is 4 times 5 times 6, all over 2A, which is 2 times 5. Calculator time. So fraction -13 plus square root 13 squared minus 4 parentheses 5 parentheses 6 all over 2 parentheses 5. That gives me -3/5. You can actually see that. So one of the answers is -3/5. Now I'm going to back up, get up to that plus sign next to the square root, delete it, change it to a minus sign, and I get -2 for my other answer. So my numbers for my number line, I get a -infinity, -2, -3/5, and positive infinity. First interval, -infinity to -2. Second interval, -2 to -3/5. I'm putting square brackets. Last interval, negative 3/5 to positive infinity. I'm going to roll the dice right now, and I believe this is the answer. And I kind of expect you at some point to start gambling a little bit on your homework. Don't gamble on the test, but just to save some time, I could do a table. My table would have these intervals, negative infinity to negative 2, negative 2 to negative 3/5, negative 3/5 to infinity. This interval I try a negative 3. Here, negative 1 is between those. Here it goes from positive to negative. I try a 0. I'll start maybe checking every other one to make sure my guesses are still consistently good. Hey, 34 is not good. Oh, it's going to be very unpleasant because I'm going to get square roots that I'm going to have to deal with. This one I'll do the full blown. So I'm going to go x squared plus 5x minus 4 equals 0. Quadratic formula because that's prime. A equals to 1. B equals to 5, C equals to negative 4. I'm going to go negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 4 all over 2 times 1. My answer is going to have a horrible square root. It might be really ugly. Let me see what it is. So calculator, clear, fraction, negative 5 plus square root 5 squared minus 4 times 1 times negative 4 all over 2 times 1. Horrible. I get negative 5 plus the square root of 41 over 2. I'm going to SD this because I need to know what that is as a decimal. As a decimal, it's 0.70, close enough. Now, hopefully I can still go backwards. Yes, I can. So I'm backing up, getting into the square root that I just did. I'm going to change the plus sign to a minus sign, delete, minus, equals, and I get, my calculator says this, negative 5 plus the square root of 41 over 2. I would probably, if I was doing this by hand, get negative 5 minus the square root of 41 over 2, but I'll live with my calculator's answer. And I'm going to SD it, which is negative 5.7. Really, really unpleasant number line now, and I need lots of room for this. I should get out another sheet of paper just so I don't mess this up. So my number line's going to have negative infinity, and then the smaller one is this one, and I'm going to write it like that. I'm going to distribute the negative through and get negative 5 minus the square root of 41 over 2, and then I'm going to get negative 5 plus the square root of 41 over 2, and then infinity. So first interval is negative infinity to negative 5 minus the square root of 41 over 2, and round brackets because I don't have the infinities, and then negative 5 minus the square root of 41 over 2, comma, negative 5 plus the square root of 41 over 2, round parentheses, and then negative 5 plus the square root of 41 over 2, comma, infinity. So now I'm going to do my table. First one I'm going to do is negative infinity to negative 5 minus the square root of 41 over 2, and then that's equal to negative 5.7. It's important to know that so I know what number I can plug in. The next one, negative 5 minus square root of 41 over 2, comma, negative 5 plus the square root of 41 over 2, and that is 0.7, negative 5.7 to 0.7. And then the last one is going to be negative 5 plus the square root of 41 over 2, comma, infinity, and that's 0.7, comma, infinity. In the first interval, I'm going to check negative 6 because it's close, but it's in that interval. This interval goes from negative to positive. I'm going to check 0. And this interval goes from 0.7 to infinity. I'm going to check 1. And what am I going to check those numbers in? I'm going to check those numbers into x squared plus 5x minus 4 is less than 0. So first one, I'm going to go parentheses negative 6 squared plus 5 parentheses negative 6 minus 4. So I'm doing negative 6 squared plus 5 parentheses negative 6 minus 4. I want to see if that's less than 0. Forgot a parentheses here. And that gives me 2 is less than 0. That's false. The next one I'm going to do 0 squared plus 5 times 0 minus 4 is less than 0. So back up into here, delete, delete, back into the other parentheses with the negative 6, and get 0 squared plus 5 times 0 minus 4. That gives me minus 4 is less than 0. And for the last one, I'm going to go 1 squared plus 5 times 1 minus 4 is less than 0. So I'm going to change these zeros to a 1. And I get 2 is less than 0. And so first one, false. Middle one, true. Negative 4 is less than 0. Last one, false. 2 is not less than 0. My answer is the middle one. I should write it with the ugly square roots. So my answer for problem 34 should be negative 5 minus the square root of 41 over 2, which you could write that for, comma, negative 5 plus the square root of 41 over 2. The nice thing about how I structured this section, if you have your work for the first 44 problems, it's almost going to be identical. It's going to go a lot quicker the second half because I'm going to borrow all my grungy algebra work. The only difference is going to be the checking. The intervals are going to be the same because the problems more or less are the same. I'm definitely wearing out. Another quadratic formula. I'm not happy that I gave these again, but it says A is going to be 5, B is going to be 5, C is going to be negative 2. So I'm going to go, whoops, I forgot to do 5x squared plus 5x minus 2 equal to 0. So I'm going to go negative 5 plus or minus the square root of 5 squared minus 4 times 5 times negative 2 all over 2a, which is 2 times 5. Calculator time. I do not want to do this by hand. This section would be really unpleasant without a calculator. So negative 5 plus square root 5 squared minus 4 parentheses 5 parentheses negative 2 all over 2 parentheses 5. And I get negative 5 plus the square root of 65 over 10. I need to SD that, so I'm going to SD it, and it gives me 0.3. Now I'm going to back up, change the plus sign to a minus sign, delete, minus, equals, and I get this thing. My calculator gives me negative. It gives me negative, and then 5 plus the square root of 65 over 10. And I usually write that as, oops, obviously I'm getting tired, I'm sorry. It gives me negative 5 plus the square root of 65 over 10, which I'd write as negative 5 minus the square root of 65 over 10. And SD that, it's negative 1.3. I'm going to roll the dice and just bang on the middle interval. My intervals would be, have the negative infinity and then the negative 5 minus the square root of 65 over 3, and then the negative 5 plus the square root of 65 over 3. Then we'd have the infinity. I'm going to gamble, not make the whole table. That's kind of rolling the dice, but I'm 99.99% sure that any of our less than problems, the answer, how did I get 3? This should be 10. Sorry, definitely am fatiguing on you. And I'm not even writing the right intervals. Okay. Well, there's a few more problems, and I will do them, and I will not finish the second half. I'll finish the second half tomorrow when I'm maybe feeling not so drained. That's probably a good thing for you, too. If you get to the point where you're just doing what I'm doing, you're just being stupid, then it's probably time to put it away for a little bit, come back to it when your mind's a little crisper. Hopefully it gets crisper. Sometimes my mind takes days to recover. 38. It's not a special case. It's not less than or equal to some negative number, and the left side's not squared. I'm going to solve x squared plus 5x equals 6. How do I solve this? I set it equal to 0 and I factor. And this is so much nicer than the other problems. So I'm going to go x squared plus 5x minus 6 equals a 0. I'm going to factor this as x plus 6 times x minus 1 equal to 0. So nice to get a clean problem. I'm going x plus 6 equal to 0, x minus 1 equal to 0. I get x equal to negative 6, x equal to 1. My number line is going to have a negative infinity, a negative 6, a positive 1, positive infinity. I'm going to pick up some square brackets. I'm going to have a negative infinity to negative 6, a negative 6 to positive 1, a positive 1 to infinity, and now let me do a real table. So intervals, negative infinity to negative 6, negative 6 to positive 1, positive 1 to infinity, number to check, negative 7, 0, and 2. You can check different numbers, but those make sense. Now I'm going to check to see if x squared plus 5x is less than or equal to 6. That's the original problem. So the first one I'm going to go is negative 7 squared plus 5 times negative 7 less than or equal to 6. Calculator time. So parentheses negative 7 squared plus 5 times negative 7. And you get, not that you can see that, but you get 14 is less than or equal to 6. The next one, I'm going to go 0 squared plus 5 times 0 is less than or equal to 6. I'm just doing that side. So I'm going to back up here, delete the 7 and make a 0. Back into there. Delete the 7, type in a 0. And that gives me 0 is less than or equal to 6. And for the last one, I'm going to go 2 squared plus 5 times 2 is less than or equal to 6. And that gives me 14 is less than or equal to 6. Then my true-false column. This is false. 14 is not smaller than 6. This is true. 0 is smaller than 6. This is false. 14 is not smaller than 6. So my answer to 38 is going to be negative 6, comma 1. Again, look how the middle interval comes out every time for the less than, unless it's a special case. I don't think 40 is a special case, but I could tell it's a special case if I got an I when I started doing it, and then I'd have to recalibrate, but it doesn't look like one. So I'm going to go x squared equals 4x plus 12. I'm going to set it equal to 0 by minusing 4x and minus 12. Gives me x squared minus 4x minus 12 equals to 0. I'm going to factor it into x plus 2 times x minus 6 equal to 0. Hopefully your factoring is still good. Or you could use a quadratic formula if you can't factor. I'm going to go x plus 2 equal to 0, x minus 6 equal to 0. I get x equal to negative 2, x equal to 6. On my number line, I'm going to get a negative infinity, a negative 2, a positive 6, and a positive infinity. The intervals I'm going to get are negative infinity to negative 2, negative 2 to 6, 6 to infinity. Let me do the table just to convince myself. So the first interval, negative infinity to negative 2, I'm going to try negative 3. Second interval, negative 2 to 6, I'm going to try 0. Third interval, 6 to infinity, I'm going to try 7. And what am I going to try them in? X squared is less than or equal to 4x plus 12. Need to do both sides. So for the first one, I need to go negative 3 squared is less than or equal to 4 times negative 3 plus 12. Negative 3 squared, I don't need my calculator for, that's positive 9. And then 4 times negative 3 minus 12, I think, is 0. 4 times negative 3 plus 12, should I say, is 0. So the top one gives me 9 is less than 0. That's false. Positive number is not less than 0. For the second one, I'm going to go 0 squared is less than or equal to 4 times 0 plus 12. That side's 0. Let me do the other side real quickly. I think it's 12. Yeah, the other side gives me 0 is less than or equal to 12. Just so frustrating. You can't see these, sorry. That's true. And then the last one I'm going to go is 7 squared less than or equal to 4 times 7 plus 12. 7 squared is 49. And the 4 times 7 plus 12 is 40. And 49 is not less than 40. So the top one gave me 9 is smaller than 0. That's false. The middle one gave me 0 is less than 12. That's true. The last one gives me 49 is less than 40. That's false. So just like I banked, I probably shouldn't have even done the table, because for all lessons, if they're not special cases, if you do them following my steps, you get the middle interval. When you have squares, if you had cubes or fractions, it's different. Okay, 42 and 44. I promise the next group is going to go a lot easier because they're all the same problems. I flipped the less thans to greater thans. We've done most of the work. So step 1 for 42, go x squared plus 2x equal to 9. Now x squared plus 2x minus 9 equal to 0. Quadratic formula. A equal to 1, b equal to 2, c equal to negative 9. I go negative b, negative 2, plus or minus the square root of 2 squared minus 4 times 1 times negative 9, all over 2 times 1. Calculator time. So fraction negative 2 plus square root 2 squared minus 4 parentheses 1 parentheses negative 9, all over 2 times 1, and I get negative 1 plus the square root of 10, SD it, which gives me 2.16. Now I'm going to back in, get that plus sign outside the square root, change it to a minus, and I get negative 1 minus the square root of 10, SD it, and get negative 4.16. I'm going to gamble and not do my table. I would have a negative infinity, and then a negative 1 minus the square root of 10, and then a negative 1 plus the square root of 10, and then infinity. And I'm going to get round brackets, and I'm going to gamble without doing the table. If it was a test, I probably wouldn't gamble just in case something bizarre is happening. But it's not a test, and we've done a lot of these, checked a ton of tables. So negative 1 minus the square root of 10, and negative 1 plus the square root of 10. Absolutely keep your notes for this first half, because I'm going to have my notes right in my hand as I do the second half, and you'll see the benefit, because all this grungy quadratic formula work, it's going to be identical when I flip the less than to a greater than, and the problems are identical, so we're really going to appreciate that. Last one for the first half. X squared minus 5x equals 8. So x squared minus 5x minus 8 equals to 0. And then a equals to 1, b equals to -5, c equals to -8. I'm going to be lazy and not do the table again since we've probably done 15 tables already, hopefully. So I'm going to go -5 plus or minus the square root of -5 squared minus 4 times 1 times -8 all over 2 times 1. So fraction negative parentheses -5 plus square root parentheses -5 squared minus 4 parentheses 1 parentheses -8 all over 2 times 1. That gives me 5 plus the square root of 57 over 2. And now I'm going to change, eventually change, really, there it is, and get 5 minus the square root of 57 over 2. Rolling the dice completely and believing that the answer is going to be these two. This is smaller than that because it has the minus. I think it's going to be 5 minus the square root of 57 over 2, comma, 5 plus the square root of 57 over 2. If you take the time to do a table and check this out and you get something different, let me know and I will definitely make everybody know that. But I can't think of a case when we have a square and a less than. If you do this tables like I do it, that would be the middle of my table. I believe that's going to be the answer. On the test, you could roll the dice like that too. That's going to be okay. It turns out that this table strategy is used a lot in Math 220 and a lot in Math 212. Kind of in a different context, but you do the table strategy again. So save these problems. You're going to really appreciate having them handy when we go to do problems 45 and on, because they're a lot like these problems. They just have greater thans. The answers all of a sudden are going to be the outside intervals as opposed to the middle intervals, but we'll be able to do them fast. Alrighty, so that's all I got in me right now.